When I started with my fiber laser, I found that there are 4 main settings that you want to adjust to control the mark that you're going to make. Those are speed, power, frequency, and hatch, also known as fill. Speed and power are pretty self-explanatory. Probably everybody understands you can go faster or put out more or less power. Frequency, a little more difficult to understand. Hatch, you can understand that you're going to lay down some lines inside a shape. For example, this rectangle on the screen, we can select it, press the hatch button, put 1 millimeter line spacing, and we're going to fill in this box with a bunch of hash marks. But you can see right through them. If we change that to 0.1 millimeters, now much more dense. If we change the angle of that hatching, now we have a different pattern. So that's pretty self-explanatory too. There's a lot of settings you can do with hatches, but for the most part, you can understand what you're doing. Now on the other hand, the 4th setting, frequency, that's a little more difficult to understand. We can look to the right side of the screen to this little red spot button, click on it, and we can see that the spot diameter is represented visually by a circle. So we have a frequency slider here as well. It's currently set to 20,000 Hertz. Our range on this laser is 20,000 to 80,000 Hertz. So if I slide this, then we're going to see a change in this depiction. So right now, 20,000, now it's 28, now it's 40, now it's 50. You can see the circles are becoming more and more overlapped. So the same amount of power is being delivered. We set the power over in our pen settings. So all this time it's set to 10% right here on the right. So 10% of your laser's power is being distributed amongst all of these pulses. So if you have a lot more pulses and the same amount of power being delivered, it sounds pretty logical that each pulse is going to have a little bit less power in it. Now, if you scroll back a little bit and you end up back at 20,000 Hertz, there are fewer, so each pulse will have more power in it. And thus it'll be more destructive and vaporize more material as it hits your workpiece. On the other side, if you increased it all the way to 80,000 Hertz, you would end up with a lot of pulses, and they'd be much less destructive because they'd have less power in them. And that would result in heating your material more than vaporizing it. And depending on what type of material you're marking, you could end up with a polished finish with that heat, or you could end up with an oxide layer forming, resulting in a black color or another color. So I set up these 2 grids, and all we're going to do is look at changes in frequency against changes in power. So this grid on the left is going to include a hatch spacing of 0.05 millimeters, so relatively tight, and a speed of 750 millimeters per second. The grid on the right only change is going to be a tighter hatch spacing. So we're going to look at what the frequency does and how it's affected by hatch spacing. I've marked the first one on the left and I've marked the second one on the right, and I'm going to fast forward to the end and let's just look at the result. So this is the finished marking, and you can see that right around the 30% power mark on the left and let's say the 60% power mark, you can sort of draw a 30 to 45 degree angle and get a sense of where frequency actually impacts the mark. And that applies to both the 0.05 spacing and the 0.01 spacing. So the lower side of the 0.05 millimeter spacing, about 10 and 20%, even 30% power, you can see those are kind of polished marks. It doesn't show up great on this picture, but they're pretty polished. Now the right side where the 0.01 markings are, that does show up in the picture and they are quite polished. And if you do look at the 30% power, right around let's say 50-60 frequency, you can see that those markings actually change from matte tan on the left all the way to kind of a golden polish on the right. So a little more impact when we're looking at the 0.01 spacing. But this is stainless steel, and these are the kind of the impacts it's going to have. All right, so just for fun, let's look at one more. So this is a file that somebody else prepared for a MOPA style laser, and that laser can control the pulse width, and that'll produce different colors on stainless and other materials. On my laser, it's a fixed pulse width, so I can't change the duration of every pulse. It's just the same pulse, but I can change the number of the pulses. So I kind of modified this file. Speed was constant and power was constant. I just changed it to frequencies that made sense for my laser, 20 to 80 kilohertz. So marking that, this is the result I got. And you can see that anywhere above 40 kilohertz frequency, 50, 60, 70, 80, produce some interesting colors. We kind of have a green on the left and a blue just next to that, and sort of a, I want to say a reddish, plumish kind of color in the center, maybe a little bit tannish, and then sort of a gold and bronze on the second to the right, and then a silver on the right. So kind of interesting, and most of the effect is purely derived from the higher frequency. So that should be an oxide layer forming on the stainless steel that produces these colors. And that's just a higher frequency that does that. So I'm hoping that'll be a decent layman's introduction to frequency settings in EZCAD, and hopefully it'll benefit anybody who's in the same position I was in a couple of months ago. If you have any questions or comments, feel free to leave them below.